Alright, in this video we're going to talk about graphing rational functions. Graphing a rational function. Let f of x be the function p of x over q of x. Let that define a function where p of x and q of x are polynomials and the rational expression is written in lowest terms. That means everything has been factored and canceled or anything can be reduced. To sketch its graph, follow these steps. Find any vertical asymptotes first. Find any horizontal or oblique asymptotes. Find the y-intercept by evaluating f of 0, so plug the 0 in for the x. Plot the x-intercepts, if any, by solving f of x equals 0. This will be zeros of the numerator only, don't worry about the denominator, just the numerator. Determine whether the graph will intersect its non-vertical asymptote, y equals b, or y equals mx plus b by solving f of x equal b or f of x equals mx plus b. Plot any selected points as necessary. So you can use the t-chart, table of values. Choose an x value in each domain interval determined by the vertical asymptotes, and then sketch any x-intercepts, then complete the sketch. So let's do a couple of these just to practice some of these guidelines. So sketch the graph of f of x equals 2x minus 3. So first and foremost, let's see if we have any asymptotes involved. Vertical asymptotes. If I set the denominator x plus 1 equal to 0, then I know x is equal to negative 1. That's my vertical asymptote, so I'm going to draw that in. It's a vertical asymptote. I should never cross that line. My horizontal asymptotes, since the power of x matches on top and bottom, we know that's just going to be y equal to 2 on top and 1 on bottom. So y equals 2. We know that's a horizontal line. Okay? All right. Now, the y-intercept. The y-intercept is what we would get if we let 0 be x. So if I let 0, I'd get negative 3 over 1. So at negative 3 is where this is going to cross the y. Let me write this out here. The y-intercept if I said 2 times 0 minus 3 over 0 plus 1. So that's going to give me negative 3 over 1, which is negative 3. So we're going to plot a point on the y-axis at negative 3. My graph crosses right there. Crosses the y-axis at that point. What about x-intercepts? X-intercepts come only from the numerator. So 2x minus 3 equals 0. 2x equals 3. X equals 3 halves. So we cross the x-axis at 3 halves, which we know is 1.5. Okay? So it looks like that's about all we can do. The rest of the graph is going to come from just plugging some points in. So I'm going to do a t-chart here. Since it's a function, we know it has to pass the vertical line test, so we cannot, you notice how your graph is broken up into 4 little regions. If part of it plots up here, then nothing should plot down here. It looks like stuff is plotting down here in this lower section on the right side, so we know nothing should plot up here as well. So let's see what happens. If I pick some numbers, let's pick like negative 2 and negative 3. If I plug those into my, you may need some scratch paper to do this. If I plug in negative 2, I would get negative 4 minus 3. And if I put negative 2 on bottom, negative 2 plus 1. So that's going to be negative 7 over negative 1, which will come out to be positive 7. So negative 2, 7 is a point on my graph. Okay, let's try the negative 3 and see what happens. So let's see, 2 times negative 3 is negative 6 minus 3. Negative 3 plus 1 on bottom. That's negative 9 over negative 2. So positive 9 halves, which is like 4.5. So at negative 3, we're going to go up 4.5. Let's try one more point on that side, negative 4. I think I've got about enough to figure out kind of the shape of the graph and not have to do too much more with it. If I plug in negative 4, let's say that would give me negative 8 minus 3 over negative 4 plus 1. So that's negative 11 over negative 3, which is positive. Let's see, 11 divided by 3. 3.6. So at negative 4, I'm going to go up 3.6. So you kind of get the idea. If you extend your asymptotes a little further here. Sorry. Okay, and probably the same thing on the other side. Good idea of what that graph would look like. Do as many points as you want to in your table of values if you want to make your graph look better. You can only make it look better by doing more points. Let's try one more. F of x equals 1 over x squared minus 4. Now you might think this one follows the pattern of the basic curve 1 over x squared, but actually it does not, because for that to work, this would be x minus 4, have to be in x minus 4 in parentheses squared, and then of course you just have a horizontal shift going on. But so that's not what goes on in this problem. Let's look at some asymptotes first and see if that gives us any idea how this is going to work. So the vertical asymptotes, we know it's the denominator, x squared minus 4 equals 0. X squared equals 4. So x would equal plus or minus 2. So we have two vertical asymptotes here. So I'm going to draw those in at negative 2 and positive 2. Okay, my horizontal asymptote, no oblique in this one, so horizontal. Since my power is less on top than it is on bottom, we know y equals 0 is our horizontal asymptote. For y-intercepts, if I let x be 0, I get 1 over 0 minus 4, which is negative 1/4. So we know we're going to cross the y-axis at negative 1/4, which is really small, really close under there. Okay. X-intercepts, all that comes from the numerator only. And in this case, 1 is never going to equal 0, so no x-intercepts. So it looks like we're going to have to do some T-chart stuff here. So I'm going to get a table of values. Let's pick some points over, let's say, negative 3 and negative 4. Let's try that. So if I plug in negative 3, I get 1 over 9 minus 4, which will be 1/5, or 0.2. If I try the 4, 1 over 16 minus 4, I get 1/12, which is way smaller fraction. This is going to be really hard to plot. So we're talking really, really close to the horizontal asymptote here. So 1/5 is right here, and then so we're going to hug right here the asymptote. So all that can happen is that it goes up. Right there. All right. Well, let's check what happens in the middle interval here. Let's plug in. We know what happens at 0. Let's do negative 1 and 1. Since they're squaring, you should get the same symmetric value. So actually, I only have to do just positive 1 here to figure out what would happen. So I get 1 over 1 squared minus 4. So negative 1/3. That should happen at 1 and negative 1. So at -1, -1/3 would be just a little bit further down. 1, -1/3. So what I'm figuring is that we're doing like a U shape, probably in the middle here, getting closer to those asymptotes. And since this is an even graph, I would believe that probably on the right side, we're going to map up in that top section as well. Let me just, if I plugged in -3, I should get the same thing if I plug in +3. So that is true. That is what's going to happen there. So we're going to ride along that asymptote in the same way. So there's our graph completed.